As you can see, we're talking about balanced mix designs. We've done 3 in our section, in our district. This one up here, the top one, it says the date, 2010. With wrap, it was a dense graded mix. The second one was also done by TTI. They helped us out a lot. They came up with a mix design. And it kind of goes with Edith's presentation with rejuvenators. We had 3 rejuvenators, a control, and a virgin mix that are actually performing very well as we speak. And then kind of an offshoot that we got from all this other research in the past years is if we just add a super paved mix design with just a plus, adding an overlay test of 200 cycles like we would on any other project. How many of us have experience with SMA and PFCs and stuff like that? You know, just a little show of hands. So you all have basically been doing what we've been attempting to do, is just adding an overlay. There's a little bit more to the SMA. You get a little bit more structure, a little bit more oil, because you're allowed to specify. We're not specifying a minimum oil content. It's just give me an overlay test that passes and a Hamburg that passes. Simple. So here's an idea of how this works. You have your Hamburg over here on this side, and you run several different points, several different AC contents down here. You start plotting out your Hamburgs, your rut. As your AC goes up, your Hamburg's ruts go higher, but staying well under the 12.5. For the overlay, as your asphalt goes up, as your asphalt content goes up, your overlay results over here seem to climb up to 200, 300. We average about 1,000 on most of ours when things are going good. When you start seeing overlays dropping, you may have a little bit more sand that you want, but that's my personal opinion. This is the first project that we did. I believe Luinda helped us out with the mix designs. You can see how the important thing is that he took the original contractor's data. Here are the points that he made, applied out with densities, and got a Hamburg of 2.9 and we ran an overlay and got 38 cycles. 38 cycles is more or less what everyone gets, more or less in our area for overlay test. 38 cycles is not very good. We're shooting for 200, and it's something that we want to work on. Back in 2010, Luinda came in with TTI and a few other people that helped us out a lot, and they showed us that by adding 2/10 more oil, raising keeping the AC content the same, and getting, we also lowered the binder from 70 to 64. We got a 6 millimeter on rut, which is ideal. I believe that we should be between 4 and 8 is ideal for Hamburg results. And we barely squeezed out a 200. Now, of course, this is a dense graded mix. So moving on, this is just so that you all could have it. If you want to have like a little starting point and want to try this out on your districts, all of us have contracts that we could probably have somebody do it. I don't know if TTI is willing to help, but if not, we are at the Laredo district. Again, just emphasizing original contractor design, 2.9 millimeters. TTI's research with Laredo district, 6 millimeters. Very acceptable. But here's the big difference, the cycles from 38 to 200. I think that's a very good number. That mix has been down since 2010, and all but one project is still performing well. One of the highways, sorry, we had variable highways. The only reason it's not performing well is because we took it out for an overpass right in front of our office. And it's this one right here. You could see the congestion every morning. This is a morning congestion. We did the Loop 20, the Spur 400, the 59. All of them are performing well except for the Loop 20 because that's out. Since then, we cored about 50 samples, sent them to UTEP, sent them to TTI. They're running research on it, and they say that it's still performing well 7 years later. Another picture, this is peak hours, 8 o'clock in the morning. Traffic is backed up all the way a quarter mile, and we have all kinds of traffic. Typical section, 12-inch raised medium, 2 lanes per direction, 12 feet wide, 4 12-foot variable shoulders, pavement thickness, 2 inches type C, 5 inches type B, 18 inches flex base. I believe the original flex base on this was done probably like in 1998, so some of these roads have been performing pretty well. ADTs, a little knowledge of what we had. This is as of 2011. We had 15% truck traffic. I think that's increased at least double. I'm pretty sure it's more than double. This was 2 years after we placed them. You know, you could still see no cracking, no rutting. This is actually a picture of how it was before. Of course, we milled some of that out and we prevented some of that reflective cracking to coming up. Here's the other part, 59. Oh, questions? Good asphalt content, good rutting resistance. Oh, okay, no problem. Oh, okay, this was one of the questions I have. What do you think are the three variables? Are any of these any good for assisting in making a balanced mix design? Well, gave the answer away. Let's try it again. Like I said, I'm not very tech savvy, but you know, good asphalt content, 5.5 is a good number to start off with. That's something that I wish I could specify by plan note, but you know, we got a little resistance just like anybody else. Good rutting resistant Hamburg results, that's always good. I've already mentioned 4 to 8 millimeters on the Hamburg is usually a good number where you want to be at. Good crack resistant, you know, we have a number of 200. Most of the time when we do these things, we run about 5 to 6, maybe sometimes 1,000. One of the things that has always come up in the past has been contractors telling us, well, it's not a reliable test. For dense graded mixes, I believe that is true. It's not a reliable test at the lower AC binders. But once you start getting into a high AC binder content of 5.5 or 6, as we do with SMAs and TOMs, you start seeing a more accurate reading of the overlay, where you start getting all the samples coming out at about 800, 900, whatever. So that's my opinion. I'll throw out my disclaimer there. This is the Rejuvenator project for Fuji, where we attempted to use Rejuvenator. These have 30% wrap. So we came out with a virgin mix of 6.1, target asphalt content, Evotherm as a warm mix, and anti-stripping agent. All these 5 mixes, we placed about 500 tons of each, and it's still an ongoing research project, and they were on site as of yesterday, and they say it's still performing well. 30% wrap, 6.3, a little higher, was the target asphalt, Evotherm again with an anti-stripping agent. That's control. Hydro Green as a rejuvenator, 30% wrap, same thing, 6.3. I think Sika base is what we used as a warm mix additive and anti-stripping. And Road Science also participated. It came out at a 6.1, target asphalt, a 6.1, Sika base, warm mix, anti-stripping agent. Arizona, also the same, 30% wrap, and came out at a 6.1. Like I said, all of them have been performing well as of yesterday. It's basically 2 years old, and we hope to see good things. This is our attempt that if in the future we have to allow wrap back into our specs for the final riding surface, this is a route that we're going to be looking at. You know, maybe not 30%, but maybe like 20, 15. We may need it as rut numbers start climbing. When we get out of our comfort zone of 8, you may need to add some wrap to make it stiffer and bring that number down, but still working on a balanced mix design where you have to meet an overlay requirement of 200. So with that said, I'm kind of also setting the tone that not all districts have gravel, not all districts have limestone, not all districts are fortunate to have trap rock. So you could use any one of these 3 criteria if you want to use it. Explore it with your vendors, explore it with your contractors. I think during Partners in Quality is a good time to bring it up. You'll see that a lot of them want to come to the table, just are a little skittish about taking that first step. So sometimes we got to take that first step for them, and we've done that. You see, and this was the contractor's mix design. This one we've been having a few issues. I'd like to blame the hot mix, but it could also be a few issues with base, but we're not. The concern here is right now the rejuvenator and the balanced mix design that it can perform well if given the right properties and right environment. Again, here it's basically a highlight of those previous mix design. This is where we came out with the SuperPay Plus. We noticed that a PG 70 minus 22 with 6.1% asphalt will give me a Hamburg of 8, and an overlay test of 640. The other ones were pretty good. They came in. This one not so good, the 30% without any rejuvenator or any help. But all the other ones came close on the overlay test of at least meeting 200, except for the one of the contractor, which is what is currently there right now, and which is what most of us probably use in our districts, or maybe an offshoot of that. But here's the real number. So what we did in the future projects, this is some of the weight and motions that we have on FM 468 where this rejuvenator has been placed. And you could tell by the kips that we have an unusual number of large trailers passing through there. Every once in a while I see them, but they mostly are out there at night. And this is in the middle of the energy sector where Eagle Ford is traveling a lot of their heavy equipment in the middle of the night where they will not get sighted by DPS or so forth. This is how it looked. No rutting, no cracking. This is on that particular road with the high kips. And this is what the Laredo district is doing. We've implemented the SuperPay Plus. It's basically the same specs, little modifications on general notes, but it just has an overlay requirement of 200 cycles. As you can see, the first project, I won't give names as to who's getting it, but that's a very low bid price, $62 a ton. But you got to understand that it's going to be a big project. So it's got a lot of tonnage. That drove the price down a little bit. This one, again, depending on the contractor and location, if it's right in front of his front yard, I think he could give us a better price, and that's how he was awarded the project, because he was the lowest bidder, obviously. These two over here are more or less consistent numbers. We're expecting it to be anywhere between $72 to $80 a ton for the SuperPay Plus mix designs, and hopefully it'll give us a better mix. This is about average. Prices will vary with location and hauling distance. Diesel and gas prices set these prices here. From now on, all projects will be SuperPay Plus unless we have a need for, as I said, SMA and some specialty mixes where we need it, where we need to stay within the PGL. So let me see. Based on the SuperPay Plus, the first project we did, the important notes here, like I said, all this data from lot 1, we were out there testing every sample. We're making sure they stayed on target by running nuclear gauge every 1 hour to make sure they don't cheat us on the binder. Well, not cheat, that's a hard word, but they don't deviate. Sorry. Yeah. Did I say that out loud? Yeah, I think I did. But anyway, we're not here to discuss those. So Hamburgs were always pretty good, just where I want to be, between 3 and 6, and no higher than 6, and all the overlays came back. We even had a Pavetex and Division kind of confirm some of this in between. Really helps out, you know. Let me see. Here's a couple of general notes that we have different in relation to some of the research that we've done with shear testing. And I say research as a loose term because I only use it as an indicator of what we need to be doing. Tack coats, we set up 0.07. I usually get about anywhere from 50 to 80 PSI on the shear test. For those of you that know how that runs, it's basically sheared off. And that's a comfortable number that I can live with. Usually 0.07 is a good number. So we actually just specified, you know, that I think the current spec says 0.04 to 0.1. And so we just go up to 0.07. We can move it up to 0.1. And this has been working well for CBC 1H and I believe SS 1H. The tack coat, as Giselle said, we still want to give a light coat between the layers, especially if it's been open to traffic for more than 14 days. Why 14 days? Because that's usually the lifespan of your tabs if you're keeping up with your tabs for striping. Waterproofing the tarps, that's come out very recent, or it's always been there. It's a known fact that if you trap the steam in there, it creates a nice crust, keeps the material from oxidizing quicker while in transport. Another note for us is use of wrap and RAS will not be allowed on the final riding surface. The overlay test is required. Asphalt content will be determined by nuclear gauge. PG binder for all projects will be 76 minus 22. True or false? Can a balanced mix design be done with items 341 and 344? Well, they're voting. I think they got. I think we could move on. I think they got it. Oh, we got a false. It's kind of like the ethics case, the ethics class yesterday. It's yes or no. But I think it's true. You can do it. There are some exceptions. Some districts do not have the high quality aggregate, I understand, and because of shipping of A-rated source, it's kind of difficult to. So there is a margin of false, you know. But for the majority, I think we can do it. I think there is enough experience in this room that we could make anything happen. I've seen it. As long as everyone participates, and a lot of the people that are in here always hear me getting on the phone. Robert Lee says, if it's Raymond, tell him I'm not here. Texas Appa says, I'll call him back after lunch. I don't know. And sorry, Tom. Me and Tom are almost on a direct line every day. Tom Scullion and his staff has always been helpful. So that kind of concludes my presentation. The conclusion is these research projects were promoted to develop implementation and balanced mix design. So Eagle Ford Shale has challenged us to look at different approaches and engineering properties to ensure laboratory designs and trial batch with both Hamburg and overlay tester. And I mentioned again the research projects. This one's been up for 88 months, and these are roughly about 2 years. These are 2, and they're performing very well. Any questions? Any questions I could answer while they're changing presenter? Please feel free. Yes, sir. Excuse me? Usually, what's the amount of...
Question was, how many replicates do you run when you're running the overlay test?
For the overlay, we do 3. So
Question
actually,
was, what was the standard deviation for the overlay test?
Yeah, okay. So traditionally, and I'll show you in my presentation because I actually have more of a graphical, but traditionally it was fairly high. So he was talking about how contractors weren't really feeling comfortable with the results. So we actually have a new method that we're implementing now, and we're having to go back and look at this balanced mix design with that reduced standard deviation. But off the top of my head, I don't want to give you the old number because there's people in here that might not like it. It's a pretty high number. Now it's below 10% for coefficient of variation. So I think the question was, why is Texas not moving forward with the SCB or IFIT? Illinois. Okay. So I think when all of these came about, we've already had this. So everybody, I guess, has their own university sponsoring their cracking test, and we've had TTI doing the overlay for many years, so we weren't willing to give up on it just to adopt another state's cracking test. So we actually have those jigs in our lab to run those tests as well. So on a lot of them, we have compared the coefficient of standard or the standard deviation versus the overlay test, and it wasn't worth switching over to that since we've already vested so much time and effort into the overlay. Yeah, we've got years of data. Even though we're just now doing this balanced mix design, we've been running information only tests since the overlay came out. So we've got at least 10 years worth of data. So the question is, are we proposing to implement this new overlay test? And the answer is yes. So the test procedure has actually already been changed. We had a research project with UT El Paso, and they went through, and like I said, we've done years and years of work with TTI, and we got a new set of eyes on it. UTEP came up with this new method, and they took the standard deviation. Like I said, I don't want to give you the number, but it's extremely, extremely high. And now it's below 10%. So we were pretty happy with the results. And we run the test the exact same way. It's just how we analyze the data. So all the data we had for the previous 10 years is not thrown away. We have those raw files, and we've gone back and we've run it under this new method. And we've seen the standard deviations go like this. And I'll show on the, Richard's giving me the,
Go.
Give me the thing.
Stacy. That's going to be a tough question to repeat.
Yeah.
So basically, that was like a question in 27 parts. Yeah. The question is that why we have data showing that balanced mix design could be done with wrap. Why are we switching to mixes without wrap? Is that basically it? Yeah. Well, like I said, this data was done in 2010. We have rejuvenators. We do see that the wrap is getting very inconsistent. There's a lot of variables. These mixes were actually babied a lot where we had to be there, a little bit more often. And sometimes contractors didn't like us telling them how to fix their plants. And that happens more than often. It's like, you can't tell me how to run my plant, and I won't. But I give suggestions, and, sometimes, we get into a lot of conflict of, well, shut down or this and that, and it's easier. We have less variables with less wrap. That is for sure. And like I said, in some cases, they're going to need to use wrap. There's no doubt about it. What we're saying is, if you have good aggregate, use your good aggregate. Use it virgin so it'll last longer. It'll give you the performance that you want to get out of it. That's my opinion. And I want to get the best bang for my buck. And we're not really saving a whole lot of money by allowing contractors to use wrap in the mix. We're not. I think we're losing money because we're having to go and seal coat or chip seal those projects a lot quicker than versus these projects that are 7 to 3 years old. So that's my opinion on that. I don't know. I don't think I answered your question, but I think I gave you a good answer. And we could talk later tonight.
Yeah, hey, I think to just touch on that real quick, and I've been told I have a few minutes to do my whole presentation. So to touch on that, though, I think when wrap first started being utilized, it was over-abused. And so people are feeling that they need to take it out to get back to the performance they expect. So with this balanced mix design, all we're doing is just putting more binder back into the mix. And one thing we're doing, that a lot of districts have taken it out altogether because they said, we don't know how to use it efficiently, apparently, because we have failing pavements. So let's take it out. Let's go back to basics. Once we feel comfortable, we'll start adding it in at rates that we feel comfortable with. I think that hopefully answered a little better. So originally, this was supposed to, I think, go before Ramon, and it would have given you a little front story on why we're even looking at balanced mix design. But I think we've covered a lot of it. So is there anybody in here that doesn't really have the idea of what balanced mix design is? Everybody feels pretty good about it so far? Okay, so I'll just kind of go through this really quick. So we've got a lot of dry mixes, and we've got these restrictive specifications like Ramon was talking about that don't allow contractors to utilize the materials that are best available to them. And currently, one of our big pushes has been implement SuperPave, and what people are realizing is they can decrease their number of gyrations on the SuperPave and increase the lab densities, and you're able to get a little bit more binder in there. But you can only do that so much, and you're going to kind of max out on those materials. So we were thinking we need a better way to really optimize these materials. And then this goes kind of to the idea of the wrap. So we can continue to use these things, but without really understanding them and start really focusing on the performance of the pavement, it's not attainable for us. So what we need to do is find a new way. And so what we're trying to look at is focusing more on the performance side and less on what's going into the mix. So the idea is, yeah, if we focus on individual material qualities, although that's good, you're only as good as the materials that are going into it, that'll only take you so far. So with the idea of a recipe, you can tell somebody how to make it. So a good question is, what constitutes a good cake? Is it how the person actually made the cake, or is it the fact that the cake tastes good? So we're using that same methodology with the mix. Do you really care how they make it as long as they're giving you the performance that you're after? So our idea with this balanced mix design, and what Texas and other parts of the country are looking at, is let's stop using the recipe to determine if the cake tastes good, and let's just measure the performance of it. So currently, as Ramon was kind of touching on, and this is really an issue across the country, is what's more important to you? Is it cracking or rutting resistance? In Texas, right now, I would say it's probably more cracking because we've dried up a lot of our mixes trying to prevent rutting. But then in the next few years, we'll probably have all this extra asphalt in there, and we'll start seeing rutting again. So we're constantly in this cycle of chasing performance. So you ask yourself, well, can I have both? And like he touched on, you absolutely can. SMA is a great candidate that does both, but can it do it economically? We can't afford to put SMA everywhere. So if you had to choose between economics and performance, is there a good choice? You can only afford so much, and you have to cover all of your roads, but at the same time, you don't want to pay for something that is not performing. And traditionally in Texas, we've been focusing more on the economics in recent years with adding all of the recycle. And I think what we've done is we put too much in there and focused less on the performance aspect. So instead of just saying, hey, we think good hot mix should look this way, why don't we just focus on performance? So this is kind of just the background of why we're even looking at this balanced mix design. And the idea is to remove a lot of restrictions from contractors, allow them to do what they need to, what's locally available, if dollars can be better spent on one material versus another, and that way we can really get the performance that we're after. So really, to break it down, the idea is to optimize and balance, and I'm going to try to do quick because I think Richard's eyeballing me. But balanced mix design, the idea is to optimize the mix to provide needed performance and balance between stability and durability. So when we were coming up, we're trying to come up with a mock spec. This is really just an overall everything that is going to go into the mix. And we can easily optimize each one of these things. Gradation, you can use these new methods like Bailey method. Aggregates, you can definitely use higher quality aggregates, things like that. But for the sake of this argument, we're really just looking at the mixed performance evaluation. The one that we're really looking at in Texas, stability, one of them, and we use a Hamburg wheel tracker. Other states may use the APA. That's just a rutting indicator. The other one we're looking at is durability. And like the gentleman asked, why do we use the overlay? That's just what we've vested all of our time and money into. And until we're proven that there's something just light years better, we're going to keep doing the same method. So for us, we're using the Texas overlay, but there are other ones, SCB, other ones across the country. So kind of a graphical. This is based on our old overlay where we were measuring the cycles, but this is an idea of the Hamburg and then the overlay. And really the idea here is with the Hamburg, we have a minimum requirement of 10,000 passes, and that's just based on how our current specification is set up. And that would give us a 5.7 asphalt content. If you look at the overlay with a minimum of 300, and these are arbitrary numbers really, we're still in the process of rewriting something so we can optimize this better, but you see that it brings you at a 5.3. So you see there's still a fairly large difference, but this is the idea of balance. Now I think what we need to focus on more is the optimization, where you can find more of a central number that passes both of these pretty well. So using our new overlay, just to give you an idea, this is how we're doing it now, and it's relying more on the fracture energy. So it's how hard is it to initiate that crack, and how hard is it for that crack to grow or propagate. So under this new, and we can go into this outside of this, but this is this is what we're deeming as a better mix, and we've got some other graphs set up, and we're trying to determine where these boundaries need to be. But ultimately, a balanced mix design would look something like this. So although it's not as pretty, we're deeming this quadrant as good cracking resistance. And then you see this Hamburg actually failed right before 15,000 passes, which this is its minimum. Well, it was easy for us to pick up running this balanced mix design. All we did was went back and added lime. This was a in-house mix design, in-house mix. We did everything, sampled the aggregates ourselves. And we went back, added lime. The overlay passed with flying colors, and the Hamburg did as well. And like I said, we still need to focus more on that optimization. So how you can get the very best economically. This is something that University of Illinois is doing. It's something very similar. They're using the DCT, which is the direct compact tension disc compact tension test, and Hamburg. So it's still a cracking test and a rutting test. And just because it's a super mix doesn't necessarily mean you always have to use that mix for everything. You see some of these other ones are better used other places. Another way that we're using this, we've been doing LRA, which is limestone rock asphalt, in Uvalde for forever. And we've always just relied on the Veeam stability, which is a confining test, and it measures the mix's ability to resist flow. But the problem is you can get an extremely dry mix. It'll resist the flow, but then when you put it on the pavement, it'll crack. So we've actually implemented a balanced mix design type approach with a Canabro, and that helps determine if it's going to actually hold together as well. So ultimately, we're still working on the spec development, but the two things we really care about is just to relax the constraints, to give the contractors more freedom, but at the same time, just specify the end performance that we're after. And then just to kind of touch on a few other things, almost real quick. One thing we actually have gotten onto the NCAT track this year. So within the next few years, we should have something. So if you're not familiar, this is a track in Auburn. We have these two sections right here. So one we're going to do under the traditional method, and then the other one will be done with the balanced mix design approach. All of the material will come from Texas. We haul it down there. They build it. They have traffic that runs this loop continuously. So it'll have the same traffic. It'll have the same environmental loading, and then we can test both of them. They actually pull cores and run tests on this, and then you have access to everybody else's data on this as well. So it's pretty hard to get onto. We've just gotten a few sections on it. So hopefully we'll get more of a real-life scenario. And then I was going to lead into Raymond saying we've also got 4 districts that have done something similar to this, Laredo being one of them, and they've used some form or another of balanced mix design.